these days, what we normally do is we build one big satellite with lots of instruments on it, and we put it into orbit around the Earth. And it goes around the Earth, and the Earth rotates, and the orbit precesses a little bit. But normally, if you wanted to see something underneath the satellite and revisit it again and look down at the exact same spot, you'd have to wait a few days. Certainly tens of hours, sometimes days. And what we can do, if instead of having a giant satellite with lots of instruments on it, if we break that up into lots of little satellites, they're much cheaper. Instead of $1 billion, they're more like $1 million, so 1,000 times cheaper. And you can have more of them, which means that you can cover the Earth at the same time. And you can see the same spot repeatedly with only minutes in between each observation. So this is really important for covering observations of the Earth for agriculture, for weather. Weather is very important, so getting weather sensors on these nanosatellite platforms and constellations of them is really important. Communications is another one, and just being able to do a better job of gathering data around the Earth for disaster monitoring and other types of, events where you really need to respond quickly and rapidly. And then you can think about, when you have this network and these distributed sensors, you can think about autonomy and how they can control the observations that they're making. They can schedule them, they can route the data, they can optimize using their power and propulsion resources to make these observations, and couple that with all of the forecasting and prediction models that are running on the ground that we use every day when we wake up in the morning and turn on the weather. These models could be coupled to tell the satellites when the models aren't performing well and when they have metrics that need to be improved, and the satellites could be tasked to immediately respond and make the model better. And that could all happen autonomously without humans in the loop. So we could really start to have some coupled responsive observation prediction systems that are much more accurate.